Okay, we're going to go ahead and get started on talking about vectors. And first we're going to discuss what a vector is, what it's good for, what it's not good for. And then, of course, I'll give you an example of using a vector. Most students have a problem with vectors, not in the use of primitive data types such as integers, doubles, floats, but using vectors with user-defined data types such as your own customer object, etc. So I'm going to give you an example of using a vector using with a data type that you create, which is going to be kind of the first thing you do in your project. When you start your project, you're going to be working probably with vectors first, and then we'll convert it to a linked list, which is kind of the next. Vectors are pretty much the first kind of good memory that you, or basically memory management is a lot about what you're going to be learning this quarter. It starts with dynamic memory, then vectors, then linked lists, and then binary trees. You know, essentially the best is last of binary trees. We talked about dynamic memory last week, but vectors are kind of just an extension of dynamic memory, and essentially it is dynamic memory. But it's made it so it's easier to work with. One thing about vectors is, which is basically what they're weak in, which is pretty much what dynamic memory, the problem with dynamic memory is. And last week when we declared or we created dynamic memory, such as doing something like this, creating an array of integers. We created a dynamic memory array of 3 integers with a line like that. The problem with this is, the memory is off the heap, and you, of course, you got to free it. You got to delete iArray. But the issue is here is even though you can, this is something that you can look at and decide what the size is. It's not static as far as how big it is. But once you declare it, you can't make it bigger. You can't just decide here to add one more. You can't just decide to use iArray and just add another element onto it. And that's the main issue with dynamic memory. And the reason for that, we'll go ahead and go to the whiteboard here. And let's see, I got a few things to deal with here. Looks like I might let me pause this and clear it up, and I'll come back. Okay, so we're talking last week at how we have an array here, and essentially we've got an address that it points to, such as address 10, and this guy is at address 10. Then it goes up by 4 bytes each time to 14, and then finally to the last address, which is 18. Now the problem being is we asked the operating for this contiguous block of memory, the operating system for this contiguous block of memory, but we can't after the fact just go and say, okay, we want one more here. This is the issue with, and it's also the weakness with vectors, because vectors is dynamic memory. It's just made to be easier. And the reason why is because at this address, we don't know if the address here is clear or if another process is using it. Because when you initially ask for the memory, what the operating system is going to do, you ask for 3 integers, is it's going to find a block of 12 bytes altogether contiguously. And the problem with that being is, what if another process is using the memory that's adjacent to it? Meaning that, hey, the next contiguous block would be address 22, and from 22 to 26 would be your next number. But what if another process is using that memory? So we can't do that. Essentially, so you can only get memory, and you can only ask for memory in blocks of in order memory, and you can't just add on to it. And that's the problem with dynamic memory and vectors itself. Now that's why we have what we call linked lists, and linked lists solve this problem. But it has another weakness, because dynamic memory in arrays, it's easy to access. It's fast. We know exactly where the memory's at, exactly what address it's located at. But a linked list, you actually have to go from one link to the next, and you have to start here going through all these numbers to get to the last one. So that's the issue with linked lists, which is, of course, we got another solution called binary trees. But the whole reason why we have linked lists and binary trees is because of this problem with dynamic memory and arrays. Because it's contiguous and in order, we can't just ask for one more. And that's what we are working with when we're dealing with vectors, is basically dynamic memory, what I talked about in my last video. However, vectors is a nice little tool because it makes it easy to work with, and what a vector will do is, since it does use this behavior, such as creating arrays of a specific type for a specific size, but it's all in a nice library that makes it easy to work with. And not only that, but it's not type specific. You can determine the data type that the vector is going to hold when the program runs. So it's done during runtime. It doesn't need to be done during compile time. Here is dynamic memory, that is, the type of the memory is declared during compile time, meaning that we can't change this memory to a different type during runtime. So essentially, that's a weakness of dynamic memory that vectors basically solve, but it still does not solve that problem of just adding one more. So essentially, what a vector does is it will create your first block of memory, and then when let's say we create a block of memory that's the size of 3. And then when you essentially get done using up this block of 3, what it'll do is it will automatically double the size of that memory, and then it will copy from the old size down and make a whole nother array that represents more memory for your previous array. And vectors make it so that you don't have to do a lot of memory management. It handles most of it for you. The only issue is the behavior of when you run out of your vector size. You start with so much, you use up that memory. It doubles the size automatically and does that process of copying from the previous array over to the new array that's bigger. That's inefficient. And so that's one other drawback of vectors. The good thing about vectors is that it is able to give you dynamic memory that is managed, and you can have it. It's not type specific, so it could be any kind of data type you want. And they're actually fairly easy to use, and they're probably going to be the first. The way that you begin your project is using vectors. And then, of course, when we start creating our own linked list next week, you're eventually going to be converting your initial project start from using a vector to a linked list. So let's go ahead and get started on playing around with a vector. But I'm going to give you an example of a vector with a user-defined data type, such as a customer data type that I've created that we can implement. Okay, so vectors are slick. They can be used a lot of ways. There's a lot of documentation about them. And one other thing about vectors is, there's a lot. Some people hate them. Some of them love them. Some people say that it's not professional to use them because they got some inner issues because they are standard. It's standardized and basically when you're making software that works in multiple operating systems, the code tends to get a little bit extreme. But let's go ahead and create an array of customers and print them. And then we're going to free up that memory. I believe you still have to free up vectors when you're done. I don't think it does it for you. But first, it starts with declaring the vector library. and then you can instantiate a vector, and you can do it of any data type. If you want to create a vector of integers, you would declare that you want a vector, and then this is going to be the template. This is going to be where you tell it the data type you want the vector to store. You put in here the data type that, well, I want a vector of integers, and it's going to be called iVector. And now, what's nice about this is you don't have to ask for the memory. You can set the size. You can set the size of the vector. There's different different arguments that you can send into the constructor where you can put in the size of the vector. I believe if we want a vector of 201 integers, I believe you just put 201 in there. And of course, when we use up that 201, it's going to double to 402 and copy everything over. So this is the first start of using a vector, and then you can just use a normal array-based behavior with the vector. Since I have an integer vector, I'm going to go ahead and change the name to iVect, and now I can use a for loop to assign values to that vector. Using our normal subscript, just like an array. Okay, so let's go here. We got use of a normal subscript, just like an array. We fill up the vector. And then we can then print the vector. Fairly easy. Create the vector, tell it what data type you want to store, give it a name, give it a size. Fill up the vector, print the vector. And remember, this is just dynamic memory. This is just like using that new operator as an array. It's just happening inside of an object, and it's also templated, which we're going to be getting to. I believe we're starting our linked lists on the next chapter, and we're going to also make that a templated linked list. And you can use the linked list that we create together through these videos, or you can use a linked list that you create. Or a linked list that's part of, I believe there's one available for the vector or in a library, or the standard template library. Okay, so we can test this. I'm going to go ahead and do this system pause. If you're on a Unix or whatever, you guys won't have this. Okay, there's our 201 items. Now let's give you an example of a vector of a user-defined data type, and this is where most users or most students have a problem, is actually creating a vector of a library that they create. So I've got over here customer.h. Now this is a customer class. I did this all in line. I didn't build accessors for first and last name. I'm just going to be assigning the ID. And then I've got accessors to get the ID and the set ID. I just forgot to add public there. Remember, everything that you create for your own objects should have private data types inside and public accessors. Okay, so we're going to create a vector of customers. So we're going to fill the ID, and then we're going to print the ID. Okay, so now what we do is we're going to call this cvect, and instead of it being a vector of integers, it's going to be a vector of customers, and I need to include customer.h. Okay, so now what you could do for this thing is you can create a temporary customer. And when that that temporary customer is added to the vector, a copy of it's made. So so you can create the temporary customer, change the value of that temporary, and basically add it to the vector, and it becomes a whole nother separate piece of memory. So what I'm going to do here is I'm going to create a customer called temp, and I'm going to put in a for loop. We're going to create 201 of these guys. Okay, so what I can do then is I can just change the value of the customer. I can use this memory over and over and over again on the stack, and then when I add it to the vector, it's going to make a copy of it, and it's going to be a whole separate piece of memory. It's not going to be the actual address of this customer temp being put on the vector. It's going to be a copy of it being put on the vector. So we can use this memory over and over and over again to add customers onto the vector. So I'm going to set the ID of the temporary variable, and then what I'm going to do is I'm going to say, okay, put that temporary variable. One main thing though, I do want to push out or point out is a lot of times people will not set the size of the C vector. And if you're doing things this way, then what you want to use is what's called the pushback method for the vector. And what that does is essentially just uses or only adds memory as you need it. But it's good practice to probably put in, just because you know a roundabout number on how many you're going to actually use. Maybe even going back over that, so you don't have that doubling and copying over behavior, which is kind of stinky or severely inefficient. So we're going to push back the value temp. Now, since we've declared this vector as a customer vector, it knows that when we push back to be expecting a temporary or a customer data type. So this is what ties it all together right here, is when you use this template and declare that this is a vector that stores customers. So then you use the pushback and add the temporary customer. A copy of it is made, it's put onto the vector, and now what you can do is you can then use the vector from there on out to reference that memory. So what we want to do is fill the memory and then print the memory. And we can use the standard subscript syntax, and we will do a get ID, and that function is actually coming from my customer object. And what I want to do is I want to output, and then of course we will do an inline and a system pods. Okay, so create the vector, declare that it's a customer. Create a temporary customer just to put information on the vector. A copy is you adjust the memory on the stack of the temporary customer every time through the loop. Add it to the vector. A copy is made and put on the vector, and then the loop comes back again. Adjust the value of that temporary customer. Then a copy is made and it's put onto the vector. And then finally, when you're done, you print the vector. Oh, looks like we got some problems. So I'm going to figure this guy out, and I'm going to put it on pause, and then when I come back, I'll explain what the problem is. Yeah, so evidently the pushback, what it does is, since I created 400 of them, it put these ones that I'm pushing on the back at position 401 and then 402. I bet you if I just get rid of this, it'll do things properly now. Or I can use the correct subscript semantics. And let's see here. We'll do it both ways, actually. There we go. Simple. Okay, now if we created 400 of them, instead of doing the pushback, which will add it to 401, 402, and so forth, instead of pushback, what we'll do is we'll use the subscript here and essentially assign that equal to our temporary customer. And that's the notation or the semantics we want to use when we're starting with already 400 of them available. And we should have no problems with it working correctly now. Okay, so yeah, I told it to push on back, and of course it did. So in any case, vectors are literally just a dynamic memory that we talked about last week that's made to be easy for you to use and non-type specific. It still has the the weakness of dynamic memory or arrays as dynamic memory, meaning you can't just ask for one more, but it attempts to get over that by essentially taking and when you need more, just making a whole nother array and then copying from the old array to the new array so it grows in size. But of course, that is also inefficient, but it's the next step up. So essentially you're going to be learning about this quarter is memory management, the best memory to use for the job. And it starts with the lowest type of memory, which is what we talked about last week, dynamic memory or arrays on the heap. And then the next step up on your learning is vectors, which is just another form of dynamic memory, but controlled and managed. And then your next step would be linked lists, which gets over the problem of just needing one more. And finally, we get, the problem with linked lists also is it's inefficient because you have to go through to get to the last one, say you have 3 items on the linked list, to get to the last one, you have to go through the first 2 items because they're linked together, but you'll be learning more about that next week as we progress. So linked lists aren't the best get-all memory. The best memory to use is what we call binary trees, and it's what made Google their billions. Back before there used to be a website called Alta Vista that literally you would do a search on your 56K baud modem, and you go get a cup of coffee, come back, and the search was not done yet. And then you would then they came in with Google, and Google used binary trees, which are super fast, super efficient, and you would do your search, hit the key, and immediately the results were there. So you might be hearing my dog in the background here. Lucy, stop it. You might be hearing her more often. But anyways, vectors, they're the next step in your understanding of of memory. They're your first step in your project. We will be starting linked lists next week. Thank you.